Okay, so now we are going to look at probability distribution. In the previous chapter, we've learned about basic concept of probability. We've seen that probability can be measured or calculated empirically, so which means by the means of collecting our data. But we also said that probability could be worked out mathematically using functions. So probability distribution is the way we derive probability using mathematical formula or function. This one is very useful because it allows us to quantify some uncertain behavior of many random variables. As you can see on the slide as well, and in this one, we have quite a few numbers of probability, but we'll divide them in two large categories, what we call discrete or finite type of data type probability, and we also have continuous probability. So these two, as you can see from the names, has to do with the type of data that you have. One will look at discrete data, and the other one will look at continuous data. So, in case you don't know or you can't remember the difference between discrete data and continuous data, just know that usually discrete data can be counted. And continuous data, on the other hand, is usually measured. And if you have a data set in front of you, you really don't know which one is discrete, which one is continuous, ask yourself this question: can you halve this data? If you cannot, probably you are working with the discrete. One of the example is the number of students in a class, right? If you count a class, let's say our class, if we have 27 students, you always say 27. One, it's counted. Secondly, it cannot be half. You cannot say we have 26 and half student, because there's no such a thing as half a human. You get that? But on the other side, with continuous data is measured, because when you take the student, you can measure the height. You see, so you can say one is 1 meter 86, 1 meter 83, or 1 meter and half. So you can see that this data can be halves. All right, so now we have the difference between discrete and continuous out of the way. We will also now zoom in, so you know that the discrete now, under it we have what we call the binomial distribution and the Poisson distribution. So there is also a difference between these two. This one follows a certain number of criteria, which is 4 of them, and Poisson as well will be assigned to a certain type of criteria that need to be met, and they follow different formula. So now we are going to zoom in first and look at binomial distribution, how this is worked out. So now let's zoom in into binomial probability distribution, or the binomial question. So in order for a solution or something to be binomial, follow the binomial distribution, this question needs to follow, or the scenario needs to satisfy 4 conditions. The first one is RV, stand for the random variable needs to be observed a n number of time within the scenario. And the second one is that we only need 2 outcomes, either a success or a failure. By that we say something needs to be either present or absent, observed or not observed. And then having said so, also the 2 outcomes here must be mutually exclusive. By mutually exclusive means that they cannot occur at the same time. And collective exhaustive means that if you add the probability of outcome A plus the probability of outcome B, should give you 1. If you remember, 1 is the maximum you can get out of a probability. And the third condition is each outcome has an associated probability. Like I said, that outcome could have maybe a probability of 0.34, and the probability of failure for that outcome should be the complementary rule. So just 1 minus 3, 4. So this is for the scenario here. And the fourth one is that the objects are independent of each other, which means that the outcome of one does not influence the outcome of the other. So now we are going to look at a question and see how we could be checking for those four conditions in order to answer a binomial question. Okay, so now let's look at how you answer a binomial question. So usually they will ask you something like, what is the probability that X success will be occurring or will occur in a randomly drawn sample of an object? So the way we work that out is the probability of that X is equal to the combination of n over x, and we have px1 minus p, and all of it in bracket, then there's to the power of n minus x for x, which is the number of times 0, 1, 2, 3, or n. Remember, they have to be discrete. All right, so we know that our n is the sample size, x is the number of success of the outcome in the n independently drawn object, p is the probability of success, like I said, and 1 minus p is the probability of failure. So they say that the x value here represents the number of success, like I've just explained it here now, and this is called the domain. And since the number of success cannot exceed the number of trial, that's why we say the binomial distribution will be limited to integer values, including zeros. So just make sure that you read this part and you understand it as well. But this is the formula. This will make more sense as we look at the first example that we have here. I'll just call it 5.1. So it says the Zeppelin car hire company has a fleet of rental cars that includes the make Opel. Experience had shown that 1 in 4 clients request to hire an Opel. If 5 observations are randomly selected from today's booking, what is the probability or the likelihood that 2 clients will have requested an Opel? Like we said, what is the probability that X success will occur in the n object? So these are binomial questions. But we will not just jump straight into answering this. We will first look at our 4 conditions that I've kept here. So based on this example, let's assess condition 1 that say that the random variable needs to be observed n number of times. So this condition is satisfied since our random variable is observed 5 times. Like here, they said 5 reservations. So the random variable has been observed 5 times. So let me just underline it here, and I'll write here, yes, it has been observed 5x 5 times. Okay, n is equal to 5. Condition 1 is met. Condition 2, they say only 2 outcomes, success or failure. This is also satisfied since there are only 2 possible outcomes on each client request. So a client can either request an Opel car or you request another car, another brand, which is the failure. So S for success is Opel, F for failure, which means that they will request another car. And these two are mutually exclusive. They cannot happen at the same time. And then also, if we add the probability of selecting another car and selecting an Opel, these will be collectively exhaustive. You will see that now just in a moment, because they said 1 out of 4, right? So in terms of probability, this is 0.25. Sorry, this is 0.25. I'm just going to clean it up. Let me just demonstrate it here. So it's 1 out of 4, which is 0.25. if we put that in statistic, because the highest number we can get is 1 in probability, I'll say. And the probability of selecting another car then is 1 minus 0.25, which is 0.75. And you see now that they are collectively exhaustive, because when you add 0.25 plus 0.75, you get 1. Therefore, these are collectively exhaustive. And also that takes us to our third condition, because we have a probability of success, which we've already said 0.25, because they said 1 out of 4. Okay, and then we also have a probability of failure, which is 1 minus p, which is 0.75. In case you're wondering where the 0.25 came from, this 1 out of 4 gives us 0.25. And the fourth condition as well is satisfied, because the objects are independent. It doesn't mean that if you don't choose Opal, that is going to affect the other. So each client's preference request is independent on other clients. So one client can choose this, one client will choose another car, another make. They will not influence each other. So that is also satisfied. Then now we will move to our next step, which is now to find the P. And here our X is 2, because they say 2 clients will request the make. So now let's see how we can do that. If the P of X equal 2, when we know that our N is equal to 5 and our probability of success is 0.25. Now all we have to do is just to go and apply this formula here. Okay, so let me just create some space here and work that out for us quickly. So now what you will do, you will tell me P of X equal to is the combination. Remember the combination rule. Don't forget that combination of 5, 2, because it's N and X. Then you do times 0.25. You close the bracket. You put that in square. And you do, now you open another bracket, 1 minus 0.25, just following that formula right on top there, and N minus X, which is 5 minus 2. Then this will give us, first of all, that combination gives us 10, and you do 0.0625. That's the answer for that part, and this will be times 0.4219, and in the end you get 0.264. Like I always say, when you get an answer like this, the thing that you need to do now is you put that in percentage, which tells us that there is actually a 26.4% chance that 2 out of 5 randomly selected clients will request an Opal. So you see now, and feel free to pause and go back if something was not clear, but this is how you answer a binomial question. You first start by checking the categories are met, and then from there, that's when you go into substituting your values and applying this formula. Remember, C and X comes from the combination rule that we've done in our previous lecture. Okay, so let's look at another question here. Please feel free to pause and just to read the question and understand it before we go and answer it. Right. So the first thing that we need to do now is to first check for our for condition. Does this question qualify? Is it a binomial distribution question? The condition number one, obviously, we'll see that these are random variables and they are discrete because the what we measure here are insurance policies. Insurance policies can only be counted such as 0, 1, 2, 3, 4. You cannot have half a policy. You get that? So you cannot have like half a policy. It's either you have a policy or you don't. You know, so you cannot have half. So in that case, we know for sure now that we have discrete data. And the first condition, the random variable is observed 10 times. Okay, so it's been observed 10 times, so this one has been met. The second one, we only have two possible outcomes. The first one is the policy will be either surrendered before maturity, or just write before mat, and the other one will be is not surrendered. Okay, before mat. So this is also met, and we can see that both of them are mutually exclusive, which means that they cannot happen at the same time, and they are collectively exhaustive because we see that the probability of the policy being surrendered here, I'm just going to write it, which is 20%. Remember, you divide by 100, then you get 0.20. So we have this probability of surrendered, and when you do 1 minus this 0.20, you get your 0.8. So 1 minus p, 0.8, and they are collectively exhaustive because you get 1 here. So this one has been met as well. So each outcome has an associated probability. Yes, of course, we've just done that now. So this one is also met. And the fourth one is also met because the objects are independent of each other. So these trials are independent. Each policy status does not affect the other policy status. So it's either you surrender it or not. It's not affecting. Everyone can have a choice there. So we've met the four condition. Now let's go and answer question A. So they're telling us what is the probability that 4 of these 10 insurance policy would have been surrendered by maturity date. Let's go and solve that. Feel free to pause and try it by yourself before coming back to the video. Alright, so I hope you've tried it first. Let's see. We are trying to find the p of x, which is equal to 4, when we know that our n is 10 and our p is 0.2. Okay, so then based on that, the p of x equal 4 will be, if you remember our formula, combination of 10 by 4, because that's our x, and this one you do by the probability. So I'm just gonna write that. I know you've also attempted it, which is good. And let's write down the answers that we are getting. And we should get 0.088. And therefore, let's always write our final answer. Then you tell us that there is a 8.8% chance, I'm just gonna read that out, that 4, well, let me just write that, 4 out of 10 randomly selected policies will be surrendered before maturity. Now pause and see if you can attempt the second question as well. So let's read second question. They say, what is the probability that no more than 3 of these 10 policies will have been surrendered before maturity? Now this is where you need to pay attention to how the question is formulated. So no more than 3, the probability means that it could be either 0 or 1 or 2 or 3 will be surrendered. So that's what we are trying to find, is the probability of x less than or equal to 3. So this is what we call now a cumulative probability, because we need to add this individual probability together. We work them out individually, then we add them to find actual probability of all these events. So the way we do that, we will apply our addition rule. Okay, so which means I work out this, then I add, then I'll add, then I'll add. And because they are mutually exclusive events, so we have to add. So the addition of mutually exclusive events. So let me just rewrite it in this way now. So P of x less than 3 equals the probability of x equals 0 plus the probability of x equal 1 plus the probability of x equal 2 plus the probability of x equal 3, because they told us that what are the chances that no more than 3, so we have to work those individually. Feel free to pause first at this point so that you understand what is being done here. And now I'm just going to go now and work them out individually. I'll start with the P of x equals 0. So I'm just going to pause this video now so that we don't waste the time, and I'm just going to write them all out and show you the final answer. Okay, so I hope that you were also doing the calculation and during this time, and that you paused the video. So after working all these things individually following our formula, so now I'm going to have the P of x equal to less than or equal to 3. I'm just going to add all this. This is 7 plus 0269 plus 0302 plus 0201, and we should get 0.879. Like I always say, we put that now in percentage, that we have 87.9% chance that no more than 3 out of 10 policies will be, I'm just writing RS, randomly selected. So that's this is what it means now, that there is 87.9% of chance that no more than 3 out of these 10 policy randomly selected will be surrendered. Policies randomly selected will be surrendered before maturity. Okay, surrendered before, just write maturity. Okay. So this is how you would go for this question. So always pay attention to what you are asked exactly. So if it was not more than 5, then you know what to do. Then you just do for 1, 2, 3, 4, and 5. Not more than 2, just 1 and 2. But start with 0, 1, and 2. Always start with 0. Alright, so let's look at the next question as well. So the next question tells us, what is the probability that at least 2 out of 10 randomly selected policies will be surrounded before their maturity date? So let's first just write that and see what this means. It means that x is greater than or equal to 2. So out of all these 10 policy, at least 2 means that we're starting from 2 going up until 10, because this is what we have. But this is going to be a lot of work if we follow this way, by doing this cumulative probability of going to, let's say, p of x equals to 2 plus p of x equal to 3, and so on until we reach to the cumulative probability, and then the 10 here. This is going to be a lot of work. So if you remember, we spoke about the complementary rule. So if you know the probability of success, because the highest outcome is 1, you just do 1 minus that probability, then you have the rest, the complementary rule, which you've been doing. So we will apply it here by translating it in this way. So by using the complementary rule, it means that the probability of x greater than equal to 2 is equal to the probability of 1 minus the probability of x less than or equal to 1. So instead of finding the probability of from 2 going up, what we are doing, we're just finding a probability of this side from 0 until 1. Then we just do that minus to find this. Okay, pause and see if you understand that one. So but this is what we are doing. So the way I'm going to write it then will be 1 minus, same thing will apply, we will do the probability of x is equal to 0 plus the probability of x is equal to 1. Then we close them in bracket, and we will apply the same formula. You know what we did for the formula. I'm just gonna skip that for this video. We got the values of those two, so which is 0.107, adding them with 0.269, and therefore we got 1 minus 0.376, which is now equal to 0.624. Alright, which tells us now that in percentage that there is 62.4% chance that at least 2 out of 10 randomly selected policies will be surrendered before maturity. So remember, for these ones, we just used our formula and replaced it by 0 and 1. And if you remember, we've already worked this one out when we worked out B. If you still have your sheet with you, you should see that it's the same answer. We just added them and removed the 1. So that's it for a binomial question.